So we're looking at 7.5. We're looking at factoring x squared plus bx plus c. This is considered standard form. There's going to be an a right here in the next lesson, so just be wary. This gets not difficult, but different in a minute. Learning targets: factor x squared plus bx plus c and use that factoring to solve for real life problems. So you're wondering how you can use algebra tiles to factor that. I don't really use algebra tiles. I have a method that I think is going to be super easy and fun for you. I did not invent this, but whoever did is brilliant. And writing a polynomial as a product of factors is called factoring. So to factor this, we have the x squared, because x times x, and then your p and your q. Well, I'm not going to go through all of this. I'm just going to show you how to do it because we have time constraints on these videos. But the two numbers that you multiply at the end, if you have your square that we've been working with, the two numbers that you multiply at the end right here are going to go right here. And then these numbers here that you add up, those are going to go here. So basically, if you're writing this out, you're doing x squared plus bx plus c. This is your b, and this is your c. So let's actually try this, because that's what I actually feel like you guys learn really well, is when we actually do. And I know that works for me too. So I'm going to take my c, and I'm going to put it right here, the two numbers that I multiply, and the two numbers that I add. So these are multiply and add. Now, these sides right here of this x, those are going to be what the two numbers are that multiply to equal 6. They multiply to equal 6, but they add to equal 7. So what two numbers multiply to equal 6? So you need to think of the factors of 6. So 1 times 6, 2 times 3, and then think which one of these would add up to 7? Well, 1 and 6. So 1 and 6, and you're going to have x plus 1, x plus 6. And you're good to go. You've just factored. So again, let's try this. You have 8 and 9, two numbers that multiply to equal 8, but when you add them equal 9 are 1 and 8, x plus 1, x plus 8. That's supposed to be an 8. And the last one, two numbers that multiply to equal 16, but when you add them equal 10. Think of your factors of 16. You have 1 and 16. You have 2 and 8, 4 and 4, and you can see right here, these would add to equal 10 and multiply to equal 16. So x plus 2, x plus 10. Okay, let's try it with numbers that are a little more challenging. So you have a 12, and you have a negative 8. Now this right here should tell you that both of your answers, the x minus and x minus, because two numbers that multiply to equal a positive result but add to equal a negative result. So a positive times a positive is a positive, and also a negative times a negative is a positive. So both of these are going to be negative. So I'm looking for two negative numbers that would add up to equal negative 8 but multiply to equal positive 12. So that's going to be negative 6 and negative 2. And you can check this, right? Adds up to equal negative 8, multiplies to equal positive 12. And so that becomes x minus 6, x minus 2. Try it again. So 27, negative 12. You can see if this is negative right here, this is going to be a negative and a negative. So take a look at that and figure out the factors of 27. So it's 1 and 27 and 3 and 9. And that's pretty much it. So 3 and 9. So x minus 3, x minus 9, and you're done. Okay, so now what happens if this number is negative? So you can see in both of these, This number is negative now, and this one's positive, so I just switched it up on you. How dare I, right? Well, here's the thing. If this is negative, that means you have a negative and a positive, or a negative and a positive. It does not matter which order you put these in. And then this is going to be the subtraction of the two numbers. So now you're looking at subtraction instead of addition. And one of these, like I said, it doesn't matter which, is going to be negative. So think of the factors of 21, 1 and 21. If I subtract those, I get 20, so that's not going to work. So 2 doesn't work, 3 and 7. If I subtract 7 minus 3, I get 4. Booyah, we're good to go. So 7 minus 3 is 4. So this is actually x plus 7, x minus 3. This one here, again, it's a positive, and this is negative, which means one of these is going to be negative. It doesn't matter which one you make negative. It really doesn't. I just like to put it here sometimes because then you have a positive minus a negative and you can see it real easily. So if you have a negative 8, but it multiplies to equal negative 8 and it adds to equal positive 7, that means you had a positive 8 and a negative 1, because 8 minus 1 is 7, and negative 1 times 8 is negative 8. So plus, minus, and you've just factored. And remember that we use these factors to set them equal to 0 and then solve for these. We'll be doing a lot of that in Chapter 8, so don't forget that that's what we use this for. All right, I'm going to give you a chance to try, and I would like you to actually try these before you move on, because when you try something, you actually know if you've got it or not. So give these a try real quick and then check your answers. Take a moment to pause the video in 3, 2, 1, okie doke, ready to go. So I just like setting these up because when I do that, if I have multiple problems, then I just go through and I do my factoring and I don't have to worry about much as far as the setup goes. Anytime I have something where it's an easy setup, I just go ahead and do it. You guys can choose to do your own. You can do it one problem at a time. It doesn't matter. Just so long as you have a way of doing it that you know is going to work for you. I want to point out though here this negative v. Remember there's an invisible 1 in front of it. So it's actually negative 1. So numbers that multiply, here you would get negative 3, negative 1, negative 5, negative 7, negative 2, negative 12, negative 3, 5, negative 2, 15, and negative 7, 6. So check that. You should be checking this right here, basically that row. And you should have x minus 1, x minus 3, x minus 5, x minus 7, x minus 2, x minus 12, x minus 3, x plus 5, x minus 2, x plus 15, x minus 7, x plus 6. Make sure I didn't miss any signs there. Negative, 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 positive, negative, positive, negative, positive. We're good to go. So check your work. Make sure you got that. Hopefully you took a moment to do that beforehand, just to make sure. And then we're going to look at the farmer and his pumpkin patch. So the farmer plants a rectangular patch in the northeast corner of his plot of land. The area of the pumpkin patch is 600 meters. What is the area of the square plot of land? So setting up the problem. But I need to do a really quick multiplication of this so that I can actually set the problem equal to 0. That's my goal because then I can factor it. So I'm going to subtract the 600. All I did here was multiply this out. I multiplied that out. Subtract the 600 and rewrite the problem. S squared minus 70s plus 600 equals 0. And now I can factor it. So I'm going to get S minus 60 and S minus 10. By the way, S is never a good variable to use, just letting you know, because when you use an S, it looks a lot like a 5. So When I solve for this, I get x equals 60 or 10. Well, if you plug these back in, you'll see that it cannot be 60. Okay? I'm sorry, it cannot be 10. This answer right here, it doesn't make sense. So 60 is our answer. And eventually you'll get really good at doing this. So the square, 60 squared, is 3,600 meters squared. Okay? The reason this doesn't work is because this has to be equal. So this, you'll find out if you plug it in, it wouldn't work. I'll try that again real quickly. I'm going to go through this one a little faster. So multiply that out. Set it equal to 0 so that I can solve. Factor. Solve. Notice this is negative. In this particular problem, distance cannot be negative. It's not going to work. So the answer doesn't make sense. So S is equal to 20. That means the area is 20 squared or 400 feet squared. Okay. When you are factoring, if you kind of want some helpful hints, I love this diagram. It shows you that this is your two factors here, but if this is positive, if C is positive and B is a positive, then this is positive and positive. So it would be like x plus x plus. And if this is positive right here, and this is negative, you're going to have P and Q both being negative. So this would be like an x minus situation. If this is negative right here, the C is negative, then you're going to have different signs. So x plus and x minus. Just a helpful chart. If you feel like you need it, you're good to go. Let me know if you have any questions or any specific prompt that you need further explanation on. I'll be happy to help. And we'll talk to you later.